What if I told you that some of the most powerful pest control solutions ever discovered aren't sitting on shelves at the garden center for $40 a bottle, but flowing down the drain at olive oil factories right now, being treated as toxic waste? Most people don't know this, but while we're all spending hundreds of dollars every season on synthetic pesticides that kill our soil, there's a method the ancient Greeks perfected over 2,000 years ago that uses what modern corporations literally pay to dispose of. And modern science just confirmed it kills garden pests more effectively than commercial insecticides. Today I'm going to show you the exact pest control method Greek and Roman farmers used for centuries to protect their crops from ants, caterpillars, beetles, and weeds without spending a single coin. Stick around because what this does to cabbage worms is absolutely devastating. So let's get into it. Here's the forgotten Greek method that turned garbage into gold. The Romans called it amurca. When ancient Greeks pressed olives to extract oil, they didn't just get olive oil. After the oil was removed, a dark, bitter, watery residue remained at the bottom of the pressing vessels. The Greeks called this amorge. The Romans called it amurca, and both civilizations recognized it as one of the most powerful natural pesticides ever discovered. Marcus Terentius Varro, the most learned scholar of ancient Rome, documented in the 1st century BC that amurca made from crushed olives was toxic to ants, moles, and weeds. Marcus Porcius Cato, writing in his agricultural treatise De Agricultura around 160 BC, described mixing amurca with ground chalk and crushed wormwood leaves, then coating the interior of grain storage buildings with the paste. It clogged the hiding spots where insects laid eggs and released compounds that repelled grain pests and mice completely. Palladius, a Roman agricultural writer, recorded mixing amurca with cucumber extract and urine to kill caterpillars destroying cabbage crops. Pliny the Elder listed amurca as effective against woodworms and various garden insects. This wasn't fringe knowledge. This was mainstream Mediterranean agriculture for over 1,000 years. Then, we forgot it existed. Why this method disappeared. Olive oil production creates massive amounts of wastewater. Modern olive mills process millions of tons of olives annually and generate what's now called olive mill wastewater, or OMWW. It's the same substance the Greeks called amorge and the Romans called amurca, and it's classified as an environmental pollutant. The liquid is dark, bitter, acidic, and rich in organic compounds. Disposal costs olive oil producers millions of dollars every year. They pay to have it treated as toxic waste or stored in containment pits because dumping it into waterways causes contamination. It's considered a liability, a problem to solve. But here's what makes this absolutely infuriating. That same waste product, the one corporations pay to dispose of, is more effective at killing garden pests than most commercial pesticides. Research published in scientific journals over the past 2 decades confirmed that olive mill wastewater exhibits powerful insecticidal, fungicidal, and herbicidal properties. It kills beetle larvae, fruit flies, caterpillars, and fungal pathogens. And it does this because it's loaded with polyphenolic compounds that ancient farmers recognized as deadly to pests. The pesticide industry had zero incentive to tell you this. They can't patent olive waste. They can't bottle what flows free from every olive press in the Mediterranean. So they buried the knowledge the Greeks perfected and convinced farmers to buy synthetic chemicals instead. Amurca became pollution. Pesticides became profit. The science ancient Greeks got right. Modern researchers finally analyzed what made amurca so effective. The secret is polyphenols. Olive mill wastewater contains extremely high concentrations of phenolic compounds, particularly hydroxytyrosol and tyrosol. These molecules disrupt insect cell membranes, damage protective outer layers, and interfere with nervous system function in soft-bodied pests. A study published in the International Journal of Tropical Insect Science tested olive mill wastewater against Mediterranean fruit flies, one of the most destructive agricultural pests in existence. The polyphenolic extracts showed ovicidal effects, meaning they killed insect eggs before they hatched, and acted as a natural sterilant against adult flies. Another study in waste and biomass valorization tested crude olive mill wastewater against beetle larvae attacking date palms. The wastewater caused mortality rates nearly identical to commercial organophosphate insecticides, but without the neurotoxic effects on humans or beneficial insects. Research published in scientific journals documented that olive mill wastewater inhibits mycelium growth of deadly plant pathogens, including Fusarium, Pythium, Botrytis, and Verticillium. These fungi cause billions of dollars in crop losses worldwide. Amerca stops them cold. The phenolic compounds in olive waste work by inflicting bacterial and fungal membrane damage, disrupting cell wall peptidoglycan, and causing leakage of intracellular contents. In plain language, it shreds pest cells from the inside out. Ancient Greeks didn't know the chemistry, they just knew it worked. Modern science proved them right 2,000 years later. Which pests Amerca destroys? The Roman agricultural texts weren't exaggerating. Amerca is devastatingly effective against the exact pests that destroy home vegetable gardens today. Ants were the primary target documented by Varro. Amerca kills ants on contact and repels colonies from treated areas. The phenolic compounds interfere with ant pheromone trails, disrupting their ability to communicate and navigate. Greek farmers would pour diluted Amerca around the base of fruit trees and vegetable beds to create ant-free zones. Caterpillars, the larval stage of moths and butterflies that devour cabbage, broccoli, kale, and other brassicas, were controlled using Amerca mixed with other plant extracts. The Romans documented this specifically for cabbage crops. The bitter compounds in Amerca act as anti-fetants, meaning caterpillars refuse to eat plants treated with it. Beetle larvae, including weevils that destroy stored grains and root-feeding grubs that damage vegetable crops, are killed by Amerca application. Modern studies confirm this works against date palm beetles, flower beetles, and grain weevils. The Greeks coated grain storage rooms with Amerca paste specifically to prevent weevil infestations. Fungal diseases that cause root rot, leaf blight, and crop failure are suppressed by Amerca's antifungal polyphenols. Greek farmers didn't understand fungal pathogens as we do now, but they recognized that Amerca prevented the mysterious plant diseases that killed crops during wet seasons. And weeds. Amerca was used as a natural herbicide. The high concentration of salts and phenolic acids inhibits seed germination and kills young weed seedlings. Greek olive growers spread Amerca around the base of olive trees to keep competing vegetation from stealing nutrients and water. How to use Amerca in your garden today. Here's the method ancient Greeks and Romans used, adapted for modern home gardeners. This is simple. If you have access to olive oil production waste, you can do this exactly as the ancients did. If you live near an olive oil producer, ask for their wastewater. Most small batch olive mills would happily give it away because disposal costs them money. It's literally garbage they pay to get rid of. 1 gallon of olive mill wastewater can treat an entire home garden for a season. Dilute the wastewater with regular water at a ratio of 1 part Amerca to 10 parts water. The concentrated form is too acidic and phenolic for direct application. Dilution maintains effectiveness while preventing plant damage. The Romans discovered this ratio through trial and error. For ant control, pour diluted Amerca directly onto ant mounds and along trails. The ants will abandon the area within hours. Reapply after heavy rain. For caterpillar control, spray diluted Amerca onto cabbage family plants when you first notice moth activity. The bitter taste prevents egg laying and kills young caterpillars on contact. For fungal disease prevention, water diluted Amerca into the soil around susceptible plants like tomatoes and squash. The antifungal compounds are absorbed by roots and provide systemic protection. For weed control, spray concentrated or lightly diluted Amerca directly onto young weeds. It works best on seedlings before they develop deep root systems. The phenolic acids disrupt cell membranes and kill the plants within days. If you don't have access to fresh olive mill wastewater, you can approximate the effect using unfiltered, first press olive oil. Look for bottles labeled cloudy, unfiltered, or traditional press. These contain natural sediment rich in the same phenolic compounds the Greeks used. Let the bottles sit undisturbed for several weeks. A dark layer will settle at the bottom. This sediment, while less concentrated than fresh mill wastewater, contains hydroxytyrosol and other pest-fighting phenolics. Collect it, dilute it 1 part sediment to 20 parts water, and use it as a soil drench around pest-prone plants. Avoid cheap, refined olive oils. The filtering process removes exactly what you need. The method requires no special equipment, no protective gear, no measuring chemicals. Greeks did this with clay pots and wooden buckets 2,000 years before the invention of spray bottles. One critical point the Romans learned through trial and error: dilution is not optional. Concentrated Amerca will kill your plants along with the pests. The phenolic compounds that devastate insects are also toxic to delicate seedlings and young vegetables at full strength. Always dilute. Always test on a small area first. The Greeks didn't have pH meters or chemical analysis. They just observed what worked and adjusted. Start weak. Increase concentration only if pests persist. Better to under-apply and reapply then torture tomatoes on the first try. The corporate conspiracy nobody talks about. Here's the part that should make you furious. The global olive oil industry produces millions of tons of olive mill wastewater every year. And yes, it's legitimately hazardous when dumped raw into rivers. The high biological oxygen demand suffocates aquatic life. The acidity kills fish. Environmental regulations that restrict uncontrolled dumping are necessary and justified. But here's what those regulations don't address. That same waste product, when diluted and applied correctly to soil, degrades rapidly and kills pests without harming beneficial insects. Research published between 2013 and 2020 proves this. Studies show safe agricultural application is possible. The phenolic compounds break down in soil within weeks. They don't accumulate. They don't persist in groundwater. Applied properly, olive mill wastewater is less toxic to ecosystems than the synthetic pesticides currently approved for home garden use. So why isn't this researched, standardized, and sold as an approved biopesticide? Why do olive producers pay millions annually to dispose of waste that could be processed and marketed? Follow the money. The global pesticide market generates over $70 billion every year. If olive mill wastewater was approved as a commercial biopesticide, every olive-producing region could turn waste into profit. Mills could sell what they currently pay to dispose of. Small-scale organic pesticide production could undercut synthetic chemical prices by 50% or more. The chemical industry has a documented history of lobbying against natural pest control methods. They fund university agricultural programs. They influence EPA regulatory frameworks. They've successfully kept botanical pesticides and agricultural waste products in regulatory limbo for decades, while fast-tracking approval for patented synthetic compounds. This isn't conspiracy theory, this is regulatory capture. It's economics. Olive mill wastewater remains classified primarily as waste, not resource, because reclassifying it threatens established profit streams. Garden centers stock shelves with $40 bottles of neurotoxic organophosphates, while olive mills pay disposal fees for a substance that works better. The knowledge the Greeks and Romans perfected doesn't fit the patent and profit model modern agriculture runs on, so it stays forgotten. Waste instead of weapon, pollution instead of solution. Not because the science doesn't work, because it works too well for free. Why this matters now more than ever. We're poisoning our soil with synthetic pesticides that kill everything. We're spending billions on chemicals that pests develop resistance to within years. We're contaminating groundwater while olive oil producers pay millions to dispose of a substance that could replace most of what's in those spray bottles. Greek farmers 2,000 years ago had zero scientific understanding of chemistry. They just observed what worked. They pressed olives. They noticed the bitter wastewater killed insects. They used it. It worked for 1,000 years. Then we got smarter. We invented synthetic chemistry. We created patent systems and profit motives. And we stopped using what worked for free because free doesn't make money. One jug of olive waste, zero cost if you know where to ask. Complete protection against the pests you're spending hundreds of dollars a season trying to kill. Try it this season. Find a local olive oil producer. Ask for their wastewater. Dilute it. Use it. Watch the pests leave. And realize the Greeks already solved this problem before corporations convinced us we needed to buy the solution. Ancient waste. Modern science. Zero profit margin. That's why they hate it. And that's exactly why it works.